because it was fish head. Hmm. Watered down fish head. Okay. No, but the soup was watered. Yeah. You either want it to be like pretty fishy, I guess, or, you know, not just like watery fish taste. Or maybe you followed the instructions wrong. Ah! Okay. Okay. Alright. Mm-hmm. Right. Oh, can I quickly show you my thing that I did? Oh, so I've got this, which is like all my aliases that I can search. And then I can like, yeah, let's say I've got this like set up alias for this Purescript stuff. So I just like write up, set up, and I've got descriptions of like all this stuff. Yeah, it was really easy to make. I actually, because I'm using this tool called FZF, um, you you have to work in this space of pipe trickery because like that output is like what you have to parse to get certain information. So you know you got to like cut and do all this weird stuff. Um, and you can do even crazier stuff. Like you can, if it's a file, you can like have it preview in like a subsection of the screen. So like it's really useful for like previews of files, like diffs and all that stuff. Not sure if you've ever seen FCF in full action. It's quite good. Okay, yeah. It's very customizable, but has its limitations. And the good thing about what I did was I found a Python interface into it, um, which doesn't really do much, but allows me to work in Python to do some of the extraction stuff. Yeah, yeah. Anyway, all right. So PureScript. No. It just interfaces into that FCF tool. So they, oh, as in they've written like some of the scaffolding that I would probably have to write to like call it, you know, sub process or whatever. I don't have to do it. Yeah, yeah, exactly. So PureScript is JavaScript, but it's like Haskell. It's functional, and it's syntax. Yeah, it's not like dependent on JavaScript as a no. It's completely independent to JavaScript. Right. But I mean, it's worth questioning. Like, can you interface into it? I mean, let's just try and answer that now. Foreign, so use an FFI. Not sure. So calling JavaScript from PureScript. So URI is a, yeah, because URI component would be a JavaScript function that you then call with this thing. Interesting. So you can. That's pretty good. I wonder what happens though. Um, yeah, what it means. But anyway, let's just go through this. So I'll just talk about some of the tooling as well. So Spago is, I don't know if that's how you pronounce it, but Spago is like the cargo of Purescript. It handles a couple of things like cargo. So it does like dependency stuff, like you do like Spago install this some package. You can run stuff like with Spago run, which basically injects like a main for you and then just runs it as if it was like has an entry point, like a node entry point. Um, Spago build is the conversion to JavaScript. So the actual layout of this is you get a .spago folder and it installs all of the Purescript dependencies, which are just like package JSON type packages, as you can see, into that folder. And just by default, you get their preload, which contains like all your data stuff. And I keep referring to this monoidy type stuff as type classes. Is that correct? So the category of like semi-groups, monoid, functor, that that collection of I want to say ideas, or I don't know, of things in that language, is that under the umbrella of type classes, you reckon? Yeah. Yeah. I understand it's more general, but like I don't have a good name for like the collection of these things. Monoidy. But monoid is not really representative of all of these things. It's like it's just one of the things. Yeah. Mono well, these are definitely type classes, but I'm talking about like um yeah, I'm talking about all of these, like applicative, um, semi-group. Anyway, let's just go with it for now. I'm just curious about whether there's an actual official terminology or name for that. Okay. Like I want to even call it under the functional programming umbrella. Like those are the core, whatever, anyway. Yep. So the other things it gives you is like a REPL, like GHCI. So you can it's called PSCI. And then you can like interact with it. So I can find the type. Yeah, it's pretty old. No, no, no. It's actually really old. Yeah, true. Oh, 2013, 2010. Okay, yeah, there you go. Yep. So functional JavaScript compiles down to JavaScript, but uses like Haskell-like syntax that's compiled, statically typed. So here's an example of a function. You can see it's very similar to Haskell. And one of the things it does say in this is this type inference. So even though we haven't declared types, and we can, like they do somewhere, where do they do that? Yeah, they don't here, but like you could. So instead of this, I suppose you could go, um, well, this has no type, but in terms of what it returns, right? It returns a number. So I guess you could be. Hey, how do you? Oh, it's just saying that. Yeah, there's. Yeah, okay. So it's like that. Why is it saying unable to parse then? Oh, right. Yes, thank you. Just like our school then. There you go. Now it didn't complain. So I should be able to call this I am a number with nothing, and then it will just give me a number. And I guess just like Haskell, I can show that. Spago run. There we go. So very similar to Haskell. It's got the show thing, which is a type class that returns a string with this interface. Hmm. Strongly typed, readable, expressive. Yeah, I should probably state this just like as a thing to remember. Hmm. Which is kind of interruptible still. Like you can FFI into C and other languages still, right? Doesn't stop you from doing that. Sure. So yeah, this is like, and I think it's a good way to get into Haskell because it's JavaScript. You know, like one of the downsides to something like a Rust or a or Haskell is like it's too system dependent, whereas now you have this, which is just like JavaScript, so it can run in any operating system, and you don't need to battle all that configuration to get it working. Um, well, well, this Spago is just a wrapper around it, I would say, because it still has packaged JSON files, which then would have to use an npm-like package manager to download the stuff. Spago is really like a package manager that wraps that, and yeah, so there's this DAL files. Do you know? Have you heard of DAL? DAL is like a configuration language, kind of like JSON.NET. So it builds like configuration files for you, like extended JSON, stuff like that. So you can put variables in and all that stuff. I don't know it, I just know of it. But yeah. So what do we got? We got first, we have our first function. We have another function that takes some parameters where we have the name, um, f0x. So this is taking a f parameter, so like a generic already, which then takes another parameter, which is a value, is a number. And yeah, like we're doing all the case statements. So that's something that we can do. Case statement type logic. So let's do like a case statement type thing. I guess let's do the fib again. Let's see if we can do that. So fib, which takes a number, just one number, and returns a number. Let's just make sure we can see if this compiles. No. Oh, int and number are different. So number is actually float, I believe. Yeah, Haskell has int, and also, what was the other number type? Are you sure it didn't have number? Oh, integer, yeah. So number and integer must be equivalent, right? Yeah, but it has int and an integer in Haskell, right? Int and integer? Let's have a look. Yeah, so an integer, which is a I actually can't go to definition, so this is already one of the problems with Haskell is like, yeah, I'll probably have to do this. Oh yeah. T number. Yes. Yes. That's why I like it. Oh, fractional. Yeah, exactly. So this fractional types Haskell integer. What is that? That is, yeah, I think the NVim extensions are better, apparently. Yeah, I think that's what the other guy uses. Why is this not playing? Okay, hold on. I probably have to add this to a playlist, maybe. Is that why? Okay, whatever. Integer. Integer is arbitrary precision integers. Okay. Versus int, which would be not arbitrary, but fixed precision. So you want bigger ints? Integer, I guess. Yeah, and if JavaScript's integer precision is limited, then it makes sense that you can only have int and float, right? Yeah. How do you specify the precision? Ah, big ints. Okay. Yeah. Yeah. Right. 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 Cool. Yep. So we can do this. So we. Oh yeah, I was meant to test this. So let's just do fib x. So in Haskell, the dollar would be okay here, right? If I did that. Oh, and here as well. Cool. So we can do that in order to avoid all the braces, which is pretty good. God, some music's too loud. All right, so we want the cases. So that was like 0, and then let me just write it. So 0, 1, 2, 3, 4, 5, 6. Three plus. Yeah, so this was 2 plus 1, and then this becomes 2. Sorry, 2. This is, so this is the result. This is the index. So it goes 0 for 0, and then with 1 you have 1 plus 0. Oh, so this should be 1. And then for 2 you have the result of this plus 2, which equals 3, right? Anyway. It's the previous one plus the previous value. So that should be 1. And then the previous value was 3. Wait. This plus... Oh, the result. Wait. It's not? It 2 plus 1, right? Sorry, it's off this. You gotta go from this, right? So 3, 5, 8, 13. Okay, cool. I keep forgetting that it's from this row and not this row when I look at it. Yeah. So fib of 0 is going to be 0. It's going to write 4 of them, why not? Fib of x is going to be fib of x minus 2, fib of x minus 1. So we expect 6 to be 8. Let's have a look. Oh, maximum call stacks. How do you do this? That's uh because of my brackets. Because it's trying to do fib of x minus 2, so I need to put the brackets on the... Yeah, I thought these brackets were doing that, but I guess not because of the way it can't resolve the thing. Right. Yes. Yeah, that's the gotcha that I guess I need to keep remembering about this sort of functional style. Like brackets are... Yeah. So if I use the dollar, it's not really applicable here. Like here, and then I don't need the brackets, right? Yeah. And then I guess that's more readable. Yeah, it's the... Well, let's just confirm what that is again. Dollar symbol in Haskell is what? Is it just the function invocation dot... What's the name of it? Does it have like a name like, you know, fmap or... It's not fmap, but like, you know, the infix operator, what's it called? Infix? Ah. Name of dollar symbol Haskell. A dollar sign. It's just an yeah, I went back to the same thing. Okay. So we should be able to see as well in the, what is it called? The PSBI, what that is. Sorry? Oh, right. Yes. So you can either do it, yeah. So just like visually, if I don't have these, it's gonna do an infinite. Oh no, that works. Then the function call. Yeah, that's what I would have assumed. Yeah. All right. Yeah. Yeah, it's not Haskell style, and maybe if you get in... Yeah. Yeah. All right. So that was pretty easy. All right. So let's just look at the structure of a Pures program. So similar to Haskell, got modules. So if I want to write like my function in a different file. Let's call it utils. Let's put our fib function there and import it. So import, yeah, where you have to explicitly, yeah, I think that's it. I guess, oh, it does work, yeah. Still works. So does it just import everything if you, it's like import star. Yeah, okay. Cool. So we got, what have we done? We've got, oh shit, my bad. All right, so checklists, we want to do import module, recursive function. Oh, does it have list comprehension, you reckon? Should. Does this? Oh, what? Lame. No checkboxes. Nah. It depends. Like if you're in the GitHub Markdown renderer, it does render it. Yeah. Should be like an official thing. I'm kind of scared that it's not. Oh yeah. Yes, it does. I can't. Wait. This spec seems like a test. Hmm. Where? Oh, right. Yeah, yeah. But this is a testing framework, so yeah. But I mean, should cover how to test. Yeah, language reference. Yep. Oh, here we go. Language reference. All right. So we have data, and data specify the types. Oh, um, I hope they like changed the way you reference the inner thing. Maybe they've done that for this. No, you know how data records or whatever in Haskell, um, you got to do the field name and then the thing. I meant like I hope they changed that here for this thing. Yeah, yeah. So, and then that would maybe that means yeah, no collision. So let's just see. Do we get like I should probably call this something else. Data record. We did do that, didn't we? All right. So let's say we have a data person, and I import that in my main. So now let p equals person. Damn, can't do that. Wait, what? How do I... Unknown data constructor person? I did. It's here. Why can't I? Excuse me? Yeah, what's the equivalent of IO? What do they do in main? Ah, effect unit. That's what they use. Effect. How do I import effect? Import effect. Okay. Unit. Okay, so unit is this thing. Ah, do you need me to show the thing again? Okay, so unit type is actually defined as unit, IO is effect. And it looks like unknown value log. Okay, so I need to import something for log. Oh, it's an effect member. All right. Okay, it worked here. What? Yeah. Also, how come? Yeah. Also, I thought I could do the dot boy. Oh, is it because I don't need show? No. Who? Let's try the Haskell way, I guess. Confused. So, how come I can't import it? Why is this not working? Doesn't like my export of that data thing. Yeah, like I just tried fib2, which I just renamed and it works. So importing modules. Let's just import all. See what happens. Okay, it's the way that I'm importing because now it's working. Why doesn't it like the thing? Is it because I need the person dot dot? which is, I don't quite understand. Yeah. Like it says here that, yeah, that's interesting. Does Haskell have that? Yeah, let's not think about Haskell for now. Let's just think of this as a Purescript thing, and we can translate it later if it is a thing. So what? Oh, so wait. So when I try to access, so now we're accessing. So I want to access the name, which is a string. So I should just be able to do this, right? And it's saying that could not match name string. And then I don't understand this T0. T0 refers to what? General type? Oh, right. So let's just unit, I guess. Wait, can I just... No, because I'm logging, which is unit, right? It doesn't return anything, so why is that? Yeah. What? Maybe... Yeah, yep, yep, it's fine. Alright, so read up on this record thing. So it corresponds to JavaScript object, 0 or more named fields. Okay, that's it. Tagged unions. So that's the record type. Ooh, so this has ADTs. Oh, I know, but JavaScript ADTs. New type, new type, which are introduced with the data keyword. Okay, so that's kind of what I'm doing. Single constructor. Oh, wait, yeah. So that's like type class. Yeah, type class, new types. Where's the data keyword though? It's not in here. Data. Oh, kind system. The kind systems are other types. The only types that are supported in kinds are constraints. Wait, so I'm using the wrong thing? Oh, defined in type proxy data. Wait, this example though had it as a struct type thing. Maybe I have to define this function, show person, which returns a string from a person, and see if that actually... Yeah, I will. It takes a person, which I gave it. So should I write it the other way? No. Wait, what? What's the error? Oh, it's the same error. Interesting. Hmm. Yeah. Mm-hmm. Nice. Okay, that works. Wait, no, it doesn't. So it's not matching this on type string. I don't understand. So the question is, data type, why does the accessor field of string type? Yep, very weird. Oh, what? Yeah. It's the same thing. It's like it doesn't like the field going to the type. Yeah, I did, I think. I'll do, oh, right. HP. I'll do name P, because that's string room. Yeah. Unknown value. Hmm. Hmm. So they did talk about new type. Here we go. Records use type, data, or new type. Short answer, use type. Type class, type ideal, type class instances on it requires defining it for all records, which is usually not what you want. New type, if you need a type class instance and you only need to wrap a single record, and data, if you need to use a type class instance and you need to wrap a record and something else. Unfortunately, this will perform unboxing during runtime. Unboxing. This is pretty good. Should probably go through this one. Okay, so it's saying I am looking at Purescript. Okay, so this guy is saying that data types are immutable. They're persisted. So instead of like doing copies, it does new. Oh, interesting. This backtick. What does this mean? Is this like defining a list where this is the head and that's the tail? Is that a thing? Can you do that? I have no idea. It doesn't look. Yeah, it doesn't. Yeah, it looks like it's documentation because anyway. So linked lists. So they have 3 to 1. This guy's linked to 1. X. What's X? Background color. This is X. This, oh, so it's talking about when you modify it to have this stuff. Index at. Okay. Well, let's tangent for a sec. So lists or arrays, I guess. So let's create an array. Some array. Let's create in a function. Okay. I'm just gonna make it a effect function. Yeah. Oh, and I need the console log. Oops. Oh, nice. Okay. Yeah, so you should be able to nest this function in this thing, right? Yes. Cool. So I can run that, and I can create an array. Some array. I'm just gonna guess. Unable to parse mod. What? Why? I just instant. Who? Why does that not work? Like, you should be able to. Oh, this is another good tutorial. Yeah, do you see why this might be wrong if I just let this and then log that unit? Um, Unable to parse module, unexpected thing. It's like this is incomplete or something. Really? I thought, oh, sorry, I forgot the do, that's why. My bad. Yeah. No, no. This is what I wanted to do. So I should be able to access the thing. Let's see if I can just access it with like out what we know. No? Okay. Lame. Can't access like that. Sum array, that's why, maybe. Lame. So I have to do like index of sum array 1. Okay. Selected. Index at, maybe. And it doesn't know about it. So I have to import it. Is it one of those things where all of these are like, yeah, I think it might be. It's going to import data.arrays. And I don't have it. Maybe, oh, array maybe? No. Keeps going. Alright, let's have a look. Array. It requires Purescript arrays. No, that contains data array. So it's okay. to it. What do I get? Oh, here we go. Index. A to maybe A. Oh, there we go. Just to. So this data.arrays package is what I needed to actually index into it. And this data.list, data.sequence. What's the difference between list and array then? Yeah. Linked list, you're right. So what do you get with array? What's the two unfoldable? What do they mean by unfoldable? Like I know fold, which is like but what does it mean? We should be able to just read this. For all B A, B to maybe, so it's gonna have like an inner thing which returns from this tuple of A, B. How do you read this? Is this like the constrainty bit? Because I see a dot here, which is normally like the backwards thing. Yeah. I re Okay. So can I assume this is the beginning of the type signature then? Or is this the constraint still? Okay. So this is a function, right? Which takes a B and then it goes to a maybe tuple AB. And then you also give it B and it will, I guess, call this thing and return a TA, where T is what? Another whatever. But they don't tell us how it's constrained or anything. So folding is like you've got an accumulator, a function, a beginning, and like sum, right? And so what does unfold mean? Ah, right. This is not very helpful. No. Oh, test. Here we go. Mm. So look at this. We've got data again, which is something that we didn't really understand. Derive instance. That's new. Derive instance Purescript. Okay. So would this be like what we did with type classes where we could derive like odd from, yeah. So some classes have built-in compiler support and their instances can be derived from all types. For example, if you'd like to remove duplicates from an array of ADT using nub, you need an EQ and an odd instance. Rather than writing these manually, let the compiler do the work. So function, yeah, which is doing this whole removing duplicates, whatever that means. So yeah, it's deriving the type class stuff, and it only these have the following derived compiler stuff. So only EQ, odd, functor, and new type. If I like what? Okay. What do you mean? All right. Yeah, that's annoying. Yeah, right. Mm-hmm. Okay, this is just like TypeScript. No, Purescript syntax sugar for like not having to write all the type classes constraints on a generic, I guess. Oh, the derived stuff. So this is deriving from a new type in this case. And this thing would have like some derivative deriding stuff on EQ. So you get that just by specifying this. Otherwise, oh, they do specify like EQ, F, and A though. So like this is only referenced here, and yeah, like we looked at the other one, and they give it. Oh, they say new type actually. They say what? Yeah, so like in this one, they give it a name, and then they don't really use it. Yeah, it's like it doesn't have the parser to do it like in here, so you do it after it, is what I'm guessing this syntax is, right? So you define like some generics or whatever, or your type, and then afterwards you say like the type class inheritance or deriving stuff. Yeah, and it seems to be the case for this one as well. Yeah. But yeah, we just want to see unfoldable. Like, so here's the example. So we've got a U, and a U is a Um, where is it? Oh, here we go. It's an unfoldable. Yes, yes, it is. Which has this member, unfold R, which has this thing. And this guy is calling from maybe instead. And was that a member in that? No. From maybe is, yeah, part of this. And this is what it's doing. It is take. So it's like if this is a function, it's calling it and doing it, unwrapping the maybe. Oh, yeah. Oh, so unfolding here is really just taking the, unwrapping it and calling your function on the inner thing for all of the stuff. Does that mean I can have like a list of maybes and justs and then call this and it will return just the, yeah, yeah. Yeah, so you got a list of maybe and justs, like maybe types? Maybe can be just or none, right? That's what I mean, sorry. Yeah, I think we're kind of confused here. But what I mean is you've got a, yeah, but you do like these operations are typically like fold typically happens on a collection, right? And look at this, for all. So doesn't this sort of say like for everything, which means for everything in the collection? So what's the for all then? And it says convert a maybe to unfoldable like lists and arrays. Okay. So let's just, how do I, let's do maybe, yes. How do I make a maybe? Yep. And the other one would be like a just one, for example, and like a none. What's the equivalent? None. So let's make a fun. Okay. Yeah. Sorry, it's not part of the inputs. Hmm. Let's just have a look at what this means. Identity is inferred to have a polymorphic type. Hmm. For all T0 dot T0 to T0 means that for any type T0, identity can be given a value of type. So it makes sense that wrapped stuff is polymorphic because you have like maybe X can be like int, string, whatever. Sorry? Yes. Uh, so type classes apply on a generic, and this is not necessarily, it's not constraining the A or whatever. It's just saying that the generic A, which is in this maybe thing, is like could be, I guess it's doing this for all of the different types that it can be. But why do you need to write that then? Why can't you just write A? Yeah. Is it what I'm assuming though, that it's like a maybe A can be a different, like a collection of different polymorphic types, and when you define a function with that, you have, sorry, the A. Oh, is it on A or is it on maybe A then? The for all. The for all's on A. Yeah. Ah, right. Yes, you're right. So it's saying for all functions. So it's like yeah, in Rust the function thing where you say the arity of the constraint arity of the function. Hmm. Okay, so it's really talking about the higher kind function at this point. Yeah. So if we have a generic function as a parameter, we have to define this for all to say like, yes, right. Oh, it's because that A could be another like it's a wrap thing which is like a function. But what it sorry? So it's not saying that f is a function. It's just saying it's for everything that takes another parameter, which which could be like another function. It can't. It doesn't take type parameters, really? Functions don't take type parameters? Yeah. That's like a very confusing statement because don't you define a function and its signature and you say like here's the typed parameter int and oh yeah, right. So like ADT would be an example of something here. Yeah, not necessarily. Like if you have like an ADT that doesn't take a parameter, then no. But if you did, then yes. Hmm. Well, yeah, let's just write this and see what we can do with it, because I'm a little unsure about it. if I want to write something that takes a, let's just start with something like maybe, right? And I want to extract the thing out. I'm just gonna write that you have a maybe A equals A. No? Oh, wait. How do I data dot maybe me? Oh yeah. Do I have to write it like this? Oh, oh right. So how would I write a function that extracts the A from maybe? But in terms of this thing, what do I put? Just A? So like this, and then I just want to write explicitly if it's maybe A to extract the A. It doesn't like it. Oh, okay. So if, hey, oh, okay. Wait. Yeah, sorry. Yeah, sorry. Just one. Yeah, sorry. You're right. Yeah. Let's just say that. What? Hmm. Doesn't like it. Maybe the brackets? Oh, yeah. None? What's the maybe none type? Okay, nothing. But make it, no. There's no. So if it's nothing, what do I do? Yeah. Can I just assign it something there? But argument lists differ in thing. So argument list lengths differ in declaration extract. I did do that, I thought. It doesn't like it. Could not match this with F1. Trying to match maybe T0 with type F1A2 in the case of 0 of that. Yeah, I'm not 100% sure if this is the way you're meant to write for all. Yeah. Yeah, true. For all example function Purescript. For any time. we will refer to as A when given a value of type A, then I will return a value of type A. Yeah. So I could potentially just have it as A as a type and do that. And then I give it something of type. So this is where I put values in, right? Oh, wait. Right. String. Yeah. Where's your example? Yeah. Okay, I didn't give it explicit values. Maybe you're not allowed to give it explicit values. Maybe that was the problem. So if I do extract dog. Oh, now it's saying there's a problem. And if I give it that, it's not a problem. And then this is inferring for all when I just do this. So it's like important when you're dealing with generics and you're returning something of the same type. So if I do like 1 equals 1 now, see, it doesn't like it. Why? Explicit for all. Whoa, look at this. Triple arrow. Universal quantification is the for all in Haskell. I I only remember unification, which is not this, but yeah, I think that kind of makes sense. What was the other one? For all and for each. Ah, yes. Yeah. And that's like the logic upside down A, and the other one was E? Yeah, for the predicates that you're talking about. Look at that. You can do like for all, arrow for all, arrow B. So like everything has to work, and in this case only A is for all. Okay. Oh yeah, existential. That's what it was called for the for each as existential. I guess so. Oh yeah, it's an open thing. So no. Yeah, maybe we're going a bit too advanced. We really started off with lists. Just want to understand lists and this unfold business, and we went down this rabbit hole. Anyway, let's go back. Yeah. Oh yeah, sorry, arrays and how they had what their interface was. Which yes. So I had to import this guy. Oh, it's like their package type thing. So maybe by looking at this, it's kind of understandable. Like singleton takes an array and creates an array of one element. Create an array of one element. So it takes an A and returns an array A, yeah. And this uses for all because it's saying for all types A, we return an array A. Whereas you'll you'll need this. True, they're parameters to the function. Mm. And and if it's the bottom of a type, do we start to think in terms of higher kind elder functions? And because of that, and that's where I'm losing the perspective of how to relate it to it. Yep. Yeah, I don't like this function because like the whole implementations were very complicated. Whereas like, oh yeah, cons, that's a good one. Yeah, so it's like for all A um, and an array, we're going to return another array with the thing attached to the front. Yeah, it should just be array A to int, right? Well, we can write length too, I guess. See what's going on. We could. So if I write length 2, which is just going to take an array A and return int. Yes. Can I do XS or something? Okay. I mean, I've got Haskell open. I should be able to. How do I... Is it array? Oh, okay. Where am I? I'm in here. Stack run, I guess? Yeah. Okay, let's just see if this compiles. Oh. Oh. Oh, it's the same. Oh, God. Hmm. What? Oh, yeah, true. Uh, oh, yeah, true. Yeah, you're right. Sorry. Oops. So just xs equals 2 in like this. Okay, maybe that was the problem. Yeah. So, oh, yeah, yeah. It's still erroring. Okay, sure. Yeah. A. So you always have to do this, basically. Hmm. So it's just a declaration of a generic that's being used not as a function parameter, but as a... So what's the alternative then to for all existential or whatever? But what is that? What does that mean? So it was like universal quantification. So there must be like an equivalent. Oh, here we go. Why do they have explicit express higher rank types which are used extensively? So it's consistent to simply require it in all quantified types. I like explicit. Okay. Yeah. So you get it implicitly by just type inference, but if you're going to declare it with your types, you have to define it. So if I just did that, it works. Yeah, yeah. This because it's inferring it linked to. Oh shit. It's yeah. So just go with inference, I guess. I'll share my screen. There you go. Okay. So it has this operator, but I couldn't use it. What if I use the function though to? Oh wait, that's to. Yeah, I mean, yeah. So say like, yeah, this head. So could I write like this function takes an array of int like that and returns a int, and then oh, how do you write it? Array A. Wait. Oh, do I write array A? Right. All right. So what do we want some dog to do? We just want to get the head and the thing, right? So let's return head always. So in the case of like return head of just like a single thing, we're gonna return X. Oh. Okay, cool. Yeah. Okay. Can you hear me? All right, cool. So if we want to try this head cons thing, head. Hmm. I'm just trying to do XS so I can get X. Yeah, right. Yeah. But let's just read this part on pattern matching because that'll tell us. Array patterns. Here we go. So wildcard, literal. Oh, is that why? Oh yeah. Maybe that is tail. Yeah. Yeah, this is compiling. Yeah. What if it's like, I don't know. No. Yeah, true. Yeah, here we go. Specializing array destructuring syntax to arrays. Does that say that it's there and they're trying to specialize it? I don't get it. Yep. Sorry? HD? Our... Hmm. So, okay, they removed it, but how do you do it then? What's, yeah. Is this different from this one? Cons pattern, here we go. Matching arrays. Cons pattern. Yeah, they must have removed it. Yeah. Yeah. Slice has 0n. How are they storing their arrays? Like, why is it on? Like it, right. Oh, right. So it's the construction which is on. Or like worst case you on and yeah, true. And list, yeah, so list might have it. Oops. No, that's array. Yeah. Mm. Yeah, let's try list. See if we can do it. Yeah, just from a complexity point of view, they would have to rewrite something that is less performant than a linked list. Yeah. Whereas like in Haskell, everything's linked lists then, but it supports this. It just doesn't care about complexity, I guess. I don't know. For arrays, these are not arrays. How do you write an array then? Okay. Do I have to import data dot right? Stack? No. We're like doing two languages at the same time, and they're both very difficult. Mm-hmm. Yeah. And it's actually supportive. It's like, how does this work? Yeah. How does this work? Data array.io. Fair enough. Oh, is that for monads? Mutable IO arrays. Okay. ST? Standard? I don't know. Okay, so IRA? No. Import array Haskell. Data.array. I did that. Do I have to do array? Why does it show me an example? Where? Oh, yeah. Array. Maybe I can just say array. Let A equal array, and then maybe I give it a list or something. This is, yeah. Where is this? This is not a gentle. This is not gentle. Ah, you sure? Oh yeah, true. Oh yeah, true, true, true. No, it is this. Next gentle. All right. Oh, new array. Here we go. New array. So I'm just gonna import the one. Wait, this is Haskell. Yeah. Okay. So import data dot array dot io. Okay. Now it's working. New array. Right. Well, let me just try this. See if it works. Okay. Why is it erroring on put stir line? Oh, that's why. How do you even? Oh, that's right. You have to add it here. I don't know. We're just guessing. Oh my god. Google. Where is it? Oh my god. What? Oh, come on, Google. Okay, here we go. Base. Oh, ghc.arr. Is that what I want? Array. And they call it like this. Is this what I meant to do? I think it's like fixed length array, right? Oops. Alright, I added it to this guy. Let's get rid of it. And it still hates me. It's like the wrong line. Okay. But I still have to, like, return IO. Oops. Really? So it likes this. Doesn't like me. Oh, do I have to return like an IO? Ah, I'm so stupid. Maybe that's why it didn't work. Dog. Dog. Import ghc.err. Holy shit. Okay, we got it. So now, can we write a func? Oh yeah, print it. Show a index at a maybe? Oh yeah. I don't think that will work. Oh yeah. Whoa, what's all these values? Oh, because we're doing this thingy. Is that actually meaning factorial? Yeah, like the A is referencing what? Oh, the array. Oh, maybe that's index. Is that index? Oh, it's bang. Yeah, bang bang, right? So what's single bang? Do I have to bracket this? Hmm. Ah, yeah, maybe. Yeah. Yeah, of course. So, yes. But how is it getting decimals? Like this is just multiplication of integers, right? Where are the decimals coming from? You saw that, right? Like it's a tuple and then oh, okay. It's a comma. Yeah. So, can you do like XS with arrays? I don't know the type. I don't know the type. How do I do the type? Array int to int array XS X empty. Hey. It says array. So it is the type array, right? Like, it should be that, right? For array? Yeah, I do see it, this one, but um, what does that mean? So it could be anything. So I'll just go int then. Hmm. But this should work, right? Oh no, because the constructor is this thing, array, whatever. Hmm. Yeah, how do you go to the constructor in this document? Oh, here we go. Data IE. Yeah, what does the bang mean? Yeah, I see the bang I and this hash thing. What is bang I? That's cool. It's the mumbo jumbo, which is really annoying. Like, they should explain what this is. Applicable? Oh, clickable. Clickable. Array hash. Oh, yeah. Lifted type. Runtime. Mmm. Levity. These namings. Quote? This thing? Template? Meta programming? What? Oh my god! New syntactic constructions. thing interprets thing in an expression con. Oh my god. Why? Wow. Like, impressive they got to the level where they're like, yeah, we've got all this complexity. Let's do templating because we need more. Yeah. Why did we go to here? Oh, because we want to see arrays. Yeah. Okay. So, well, we learned that lists don't have XXS. Yeah, and did we see? And it definitely had no cons. Did it have cons matching on lists? Purescript? I don't, I don't think it did. Right. Oh, what? Data list not found? Shit. I have to import it? Apparently not. Okay. So X. So we want a list of X of, now let's say of int type. And we're just going to return an int. So we go empty list equals 0. X equals X. And you reckon this, right? Like that. What's the error? Maybe that's not. Oh, maybe it's list int. Unknown type. Is that why I need this? Yeah. It doesn't have linked lists, right? Let's call this list 2 so it's not confused. And then in my main, where's my main? Import list 2. Yeah, so if I want to run this, I just need to go back to my main, call this guy with a list. Is that a list? I don't know. Log dog. Oops. Oh, it's an array. Oh, look at that. Cons X XS. That's how you do it. So it's an array. So how do I write a list then? Cons x. How do they do it? Cons x xs, sorry, yeah. So cons width is the front, and then xs is the last thing. And this is, how do I write empty list? I'm back here. Empty? Oh, null. Yeah, that's a good point. Like when you look at this stuff, you should just be able to like go lists. Yeah. I just see methods though. Yeah. Unfoldable. It's not in. Oh, there's too many lists. Oh, what? Create. Hmm. Yeah. Oh, they even do this. So you can do this. So this is returning a list. How do they just find things that return a list and see how they create it? Oh, they create it with all their crazy methods. So they do this, right? And then for empty list, they use nil. And for single list, they just do x, like just cons x, and then empty. I don't know. How do I just do single? Oh, would it just be this? No. All right. Thanks. It expects two, so it's that. Yeah. Cool. Let's use it. So we want to create a list. I have no idea how to create a list, except, yeah, I know, but like, what if you just want to do it in this way? Oh, colon. So you got to have the head and then the thing. And then you have to do it like that then, right? Oh. Oh my God, it is a space. Wait. Oh, yeah, yeah. Col what? Do I have to use cons? What's this? Huh? Trying to match it with a list type, and then I put a list here, so I did like cons 1 nil, let's say. And then I put brackets to make sure it's giving me a list. And then I check it, and it says, this is so unreadable, like, It's giving me these generic types that I assume are talking about these two. Oh, wait, int. Like, which one is it referring to? It's not clear. Purescript, how to make a list. How do you make lists? Oh, cos one. Oh, right. Okay. Not enough brackets. Oh, I need to import cons? But I'm importing everything. Did not import. Because I need a bracket for this guy? Hmm. Can you run this globally? Like this? Like x equals this? Can I do that? Here? Like, I should be able to do y equals 1 here, right? Yeah. Okay, so I don't have to keep trying to put in main, at least. So I'm just going to create a list without this function. And it does work. So now I'm going to go z is equal to sum list func x. And it works. You reckon? Let's just run it, see if it... Yeah, let's just print z. Do I have to... Doesn't it get exported? No? These variables... Oh, sorry, yeah. Oh, right, yeah. Should be in the other one. Which is in list 2, right? Okay, it seems to like it. Extract. That's for all. How did this error? Why is this getting called? Maybe. When did we use maybe? Unfoldable for all? Oh yeah. Let's just get rid of this thing. Let's just get rid of that. Main. Okay. So it worked. I gave it Z, which is giving me 3. Oh, 1, yeah. So that works. And then I just want to cons, yeah, nil. Yeah, let's just give a single list. Okay, so this is working. So if I now do cons 1, 2, yeah, it's working. Okay. But I don't want to write lists like this. Like, surely there's a way to just... Yeah. Okay. I think so. I think it was just because of the other error, and maybe it was just complaining about that. But it's working, so... Oh yeah! List comprehension? Yeah. We cannot use list comprehension. Instead, to generate our original list of triples, we use a list monad. Okay. Next week. I guess you would use like... Yeah, that's bad. Oh, here we go. Differences from Haskell. Yeah, that was good to see. Numbers are generated with... What? What's that? Ah. Right. Okay. But it's giving back the same number, it's just... Right? Ah. Hmm. There you go. You have to use this thing, as we saw, and then it doesn't show you how to do it. It just shows you how to do arrays. Yeah, but if you're coming from Haskell, you'd be like, I want to use XXS, and you're like, what? So this, yeah, not having to define your accesses. Is that why it was failing? It's still wrapped inside point. Yeah, that's what we were doing, right? The object, this object. Whereas, like, if I wrote and I had to write a method and it worked. That's exactly what I did. Point is a data, yeah. So remember how I created like person and I kept trying to show the dot? Didn't work. And so the expectation here is that you get strings from the value, but what they're saying is like you don't. You still have to unwrap point. to get the object. So there's like, this thing is an object that you need to unwrap the data class to get. Yeah. Yeah. So it's treated like a higher order thing, which I guess makes it. I don't know. Yeah, let's just double check. So this was our problem, data. Whereas like this guy, for like monadic unwrappy behavior. Right. Dot name. Oh, what? Uh-oh. Oh, record, did you say? Wait. Yeah, type, right? Oh, do I have to... Oh, yeah, thanks. Well, unknown data constructor. Right. Yeah. So it's object now. Yeah? Okay. Yeah. Yeah. I mean, they're the experts. They must have a reason, right? So this is just like concatenate, right? Yeah, this is concatenate, yeah. Oh, here we go. Oh, this is arrow in Haskell, whereas they do this thing, and we saw that. Oh, wait. Wasn't it like derive? Are they talking about Purescript? Is this Purescript or Haskell? Right. So we never saw functions with um, constraints. And you would think it would be like that, right? So if you write a function, so we write let odd, yeah, some odd func for some generic, and then this is where we need for all then, right? Odd a, let's just return that. What? They say where though? Yeah. And then they have it. That's a class, yeah. These are all classes. Where's like functions? Oh, here we go. There we go. Yeah, it's just the other way around. No, it's not. Is it? I thought it was. Oh, I don't know why I thought it was like this. Hmm. Oh. So classes constrain their. What are you constraining again? Your. Oh, it's like derive? Like this. So this is like you write a type class and you can derive or inherit another type class. And it's saying here that um, this this implies this because this inherits the odd. Yeah. Oh, so this is the superclass of EQ. This is a I know, but as in like it has EQ behavior. Not not that it's object oriented or anything, but so the answer to our question is yes, we can do this. Didn't work. Because maybe do I even need this for all? Okay. And then it's is it because I need for all? Hey, look at that! Existential. What? What? What the hell? Whoa. Wow. And then I just say odd here? Hmm. Oh wait. I need yeah, sorry. I need odd T1 maybe? Yeah, there we go. Why is it existential? Why is it not for all? Oh, this is equivalent to for all? Really? Explain. Oh, so I thought existential was the opposite. That is a symbol for all. Oh, yeah, right. Because I stated before existential. and I didn't realize. So it's like the type class for all, and what's the other one? Some of there exists. Oh man, I'm just amazed that you can use that symbol. So do we ever see there exists in this? Because yeah, I just don't understand. The only time that it would differ is if you don't have for all, and it's like they say it's explicit, but where would you ever not use it in Purescript? But is it also correct to say that if you use any generic, you cannot use it without for all? So they should just infer it then, like if it's the default. I know that it's explicitly saying the description of this generic thing, but the only time it makes sense for me for them to include it is if there's a counter to using generics without it, or in some other context. Right. So why isn't this working? Is it because I don't have T1 type? I don't know what this is. Oh, sorry. Yeah. Oh. Yeah. Okay. So we can do constraint functions. Hmm. Yeah. So I downloaded some repos that actually have code. Um, yeah, that's a quite a good question. They don't even have a Spago thingy. Yeah, this is not gonna work. But they do have a package JSON. This must have been before Spago. Yes. And package Google Closure compiler. Yeah, I don't like this. Do you know what that is? I know what Closure is. Closure.js. Oh, yeah, right. Before there was TypeScript. Right. Hmm. Hmm. Right. Like. Hmm. Right. Oh no. Right. Oh, speaking of type checkers, I also looked at Flow. Yeah. Have you tried it? Okay. Yeah, it's actually much more responsive in terms of um, like you still have to compile it down and use and you know then you get your JavaScript. But in terms of developing, like from like 5 minutes of using it, like you could see that it was like very quick to say when there was problems versus TypeScript. TypeScript, TypeScript, like it is responsive, but it's very magic as well, like what you can do. I think this is like a lower set of things you can do. Like I don't think you can do all the structural typing stuff. Hmm. Foreign generic? How do I get this? Purescript foreign generic, okay. Ooh. Uh-oh. Hmm. Um, I don't. Mm, yeah, this is one of the things I think that it's right there. Why can't I install it? The library? But I don't know why I can't just. Hmm. Maybe it's something you have to. I don't know. This is not a good example, obviously, because it's too old. So look at this one. This also doesn't have a spago. Ah. This one uses spago, lambda machine. Backend uses Haskell. Hmm. Evaluating expressions in the untyped lambda calculus. It's like a server and a backend, where the front end is a spago, and the deploy is doing all this stuff for GitHub pages. I don't want to do that. Haskell. Hmm. Yeah. I think this one's a good one. File Watcher. I think I saw that and was like, yeah, that looks relatively. Okay, let's see. Can I do this? Spago. Ugh. Spago. 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 What did it say to do? Upgrade. Upgrade set. Yeah, the backwards compatibility is a problem with this thing. See? They just like lose a lot of packages. But most of the GitHub stuff is like I couldn't find stuff that was pretty recent, which is pretty bad. Like dead language. Yeah, but like surely if this was a like this is not a very popular language as you can tell because a lot of the GitHub repositories that you just search for are in that category. There's not like maybe yeah. Hmm. Yeah, like I'll show you if I search this. Okay, it's 4,000. Just go most stars. Cube compose puzzle game functional program. That sounds pretty good. 28 days ago. Hello. All right. Sounds good. Spago. Oh, but it's 28 days ago. So. Just update the README, probably. And Shark DP. This guy sounds familiar. Yeah, this guy's a Rust dude. I've seen his stuff on Rust. How do we build? Gulp. There is no script. How do you build? How do you build Gulp or Bower? Oh, yeah. npm install Purescript Gulp. All right. Let's just follow this. Gulp, Gulp, Gulp. I remember once just to kind of see what I was doing, but yeah, it's all right. Yeah, I remember it did like even before Microsoft, and it was like, how can they afford to do this? But then again, like, how does Glitch afford to do what it does? And like all the to what? Fastly. For how much? Wait, that was yeah. 8 paid things. Yeah, yeah. Yep. I did see that. Um, yeah. Okay. Oh, install. That's good. What kind of like issues do you experience? No. Okay. Hmm. Yeah, time. You should be able to create your own templates. Fair enough. Did they actually create an empty one for you? Right. I assume this is just bundling and then I had to run this index file, which is oh, wait, no? Okay. Oop, okay. Anyway, so this guy is gonna reference starting dist main. Okay, I got this main, so I can just call Fox index. Oops, and open the wrong one. Oh, it actually did something. Okay, the goal. Your goal is to create a sequence of functions which transforms the color cubes into the desired pattern shown above. To change yellow to change the yellow cubes to red cubes, add the function map to your program. You can do so by clicking the function directory. Okay. So this is our thing. If I do this, what? This is pretty cool. Rejection. Remove all the cubes with reject function. Okay. Most levels require a combination of two or more functions. Try and add a map stack. So it's really trying to teach programming, functional programming, kind of, with this thing. So map stack and map reject to your program. So that stacked another bit of yellow, and then reject the yellow. So it's rejecting all yellow. Why couldn't I just reject it? Yeah, I could. Okay. No. So then we need to like get all the yellows as a single thing. And so we want to, oh, this is cool. Yeah, so but you can't reject red. Yeah. Okay, so let's just do what he did. Oh, so we rejected so we stacked another thing, and then we reject first, sorry. We reject first, and then we stack another thing. Yeah. Oops. That makes sense. Yeah. Yeah, so we probably want to do something similar where we reject, stack. Oh no! I only have these. Oh, map. Map. Oh, so this would wait, what? What is this doing? Maps yellow to red and yellow. So what does that mean with this? Oh, so it's doing a double. Okay, sorry. So this thing becomes red yellow. Yeah, got it. Hey. All right, let's just look at the code because it clearly works. Yeah. All right. Alright, so let's look at what they use for the packages. Gulp, Pure. So really it's just these. Rimref. Yeah. Oh, Rimref is a... I think it's just like a bash runner thing. Does he use build kite? Oh yeah, right. Yeah, I think so. Mm. Mm-hmm. Yeah, yeah. Yeah. Yeah, good question. From array though, and then inside here is a thing. Oh yeah. And oh, it's up here. Oh, wait. Oh, and I don't have Spago to help me. um, helper, Purescript. Oh, was it a file? All right. Yeah. Infix 6, L6 level. Hey, we've seen that. Yeah. Is it this? Level? Level ID entry. Where? Hmm? What are you looking at? Right. So this is really saying level, and it's just referring to this function. So when we look at this, so this is taking a level, level ID. So 20. Okay. Oh, sorry. Yeah, not that one. Infix 6, L6. Yeah. So the so this is the tuple. So out of this and this, these are. Oh right, yeah. Level ID level. Yeah. Right. A wall. A cube is a types cube. It's pretty readable, at least. Say that again? Yeah. Yeah. It's just an array of stacks. Yep. And a wall is a list of stack. Okay. Instead of an array of stack. You convert an array wall to a list of wall. And that's what from folder wall. So what's this doing? Oh yeah. No. Left to right composition operator. It's equivalent to dot. Okay. Yeah, true. Okay. So this is just function dot map from foldable. So this is a co-read function. Like, what's the signature of map? It's probably like map thing function, right? Yeah, but this is yeah, this is the list from folder. Oh, yeah, so that's the functor, I guess. And it's gonna take take a thing which is this, which is an A wall, which is an array. Okay. Ooh. Yeah. 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 Right. True, true, true. And what is it? What's the actual folding functor it does though? Oh, okay. And why do they want to do that is the question. Yeah. So if we look at uh yeah, so it's wherever this is used, right? But it's like, why not just start with list then? Like, is there a uh it's like difficult to write. Yeah, yeah, yeah. See, that's pretty bad. Yeah. Like if you have to do all this conversion just to allow you to write square bracket by default. Like really the language should give you that for free. So like where's main? Oh, yeah. Oh, this is a big file. Wait, a lot of imports. So there's heaps of stuff like Monad F DOM stuff. Oh, yeah. Yeah, this is all part of it's nice that they give you DOM stuff. Hmm. Yeah, creating an LI and setting all this stuff. But you're describing your DOM document with functional programming. That's pretty cool. Hey, for all F and F is a oh, this is a record type because of this. It's like this or that. Like I'm only saying that because of the pipe. Otherwise, I would have thought a function, but is it called record? F. This is a. This is probably yeah. It's a monad. Oh, is that like effect? Oops. Well, I'm guessing this is bind, right? Like in Haskell, because it's part of monad, right? Yeah. Defined as follows the monotype class. So it you get apply if you have a type class bind, right? That's what it's saying. So you get apply with bind, where I'm not sure what apply is. But bind is a function that takes an A and a B and it, well, it would just be part of monad in Haskell, whereas in this case, it's a type class. Because they're saying that monad gets bind and applicative. So that's how they do it. Whereas, like, you could just write class monad with bind and apply, but they seem to want to break it up even more. So you can do this inference type thing, I guess. Deriving thing, whatever you want to call it. Oh, here we go. Spiky Boy. So this is this mapend? And that's mapply, I guess. Yeah, I mean, it's talking about functor and apply respectively, so. Say that again? You're cutting out. What do you say? Yeah, fmap. Oh, did I say mapend? Yeah, I meant fmap. And that's what we saw before with the whole parser stuff, right? That was fmap. And this is mapply, whatever that is. Yeah, what's apply? Oh, this is apply Purescript. It's in the prelude. Yes, it's apply. I guess you don't call it apply, you just call it apply. So this is saying to lift functions of two or more arguments to work on values wrapped with type constructor f. So you give it a function, or you give it something that, yeah, so you give it a function of ABC, and it will apply f to, yeah. Hmm. Yeah. Is it just for two though, or? So, like when I read this function, I see like this is the type signature, right? And yeah. Yeah. And so, yeah, if you look at zip as an example, you could give it like two lists and a function, and it returns like a single list with the function applied. Oh, yeah, true, true, true. Yeah, true. But I'm just thinking of an example of, yeah, yep. And yeah, okay. Oh, yeah, here we go. Apply for all FAB, FF, yeah, okay. Hmm. I guess this is like apply, and this is lift to. So it's like, yeah, wasn't wasn't this the dollar thing map? How do I go? Functor. Where's func? There we go. Okay, so for all that AFA, OB, FA, it's the same, but map can be used to tell which is right. Oh, this is the thing we were looking at, right? Like apply to left and forget about B type thing. Ah, so that's how you read it. Like you just look at it as apply to both. Yeah. Wait, is it? Hmm. Oh, they actually describe functor map here. So re-exports from functor. Map can be used to turn functions A to B into functions f of A to f of B, whose arguments and return types use the constructor f to represent some computational context. I must satisfy the following laws. Map ID is ID, so if you map on the identity, you get the identity thing. And if you compose map with f.g, you get map f dot map g. Then you get, yeah, that's map. And doesn't talk about constraints. Where do you see that? Oh, right. Yeah, it's just this thing. It's this thing. It's like dot functor. It's like dot map f apply g apply h is equal to f. Yeah, that's a good question. Well, it would be as part of their um, what was it in that number thing? Infix. Yeah, that's horrible. They should just have like at the very top, like infix one, all that. Yeah. So associative means like you do this and it's equivalent to the other way, right? Like f of g of h is equivalent to f of g, yeah, like h of g of f or something like that. You could swap them, is it? Yeah, it's this thing. Yeah, the brackets you can put in either way. Yeah, well, this is not associative, is just the key thing to know. Whereas this one is. Yeah, and if you wrote like your own type class that had like plus or something, and you had to deal with associativity, if you didn't define it to be associative, then you couldn't use this, right? Let's just say you're writing your own numerical system and you had to write, yeah, addition, subtraction, or whatever. Just focus on addition. If you wrote that method, then if you say that add was only um, allowed to have like right, yeah, when you add, you only can add to the right. Whereas like if you add something to the left, the same value, it's different. Then when you write your interface, you couldn't write apply, but you could write this, and therefore, if you had like all your stuff in like in a list, for example, and you did like a map on it, then you could do add. Yeah, sorry. Let's say you. Yeah, sorry. The associativity takes two parameters. Yeah, so So yeah. Yeah, it was that fold lift two takes two. Uh, apply. um, what? What's what's dollar? Oh, that's the. Wait, that's different to spiky dollar though. What does this mean? Oh, right. The so basically the triple. This thing is dollar, right? This is equivalent to dollar. Oh, brackets. Sorry, this is equivalent to dot. This is equivalent to like regular dollar. Yeah, and that's essentially like wrapping it in brackets, right? It's like telling you the precedence to say like this is now a h of x, h of f, yeah, g of f of x or whatever. So therefore, because of that, it changes the precedence of how it operates, right? Like it's just doing that. Oh, yeah, true. Is that what it's called? Cool. Oh, so is that applicative? No, wait. So applicative extends apply, which is what we're looking at, with pure, and can be used to create values of type f of a from values of type a, where apply provides the ability to lift functions of two or more arguments to functions whose arguments are wrapped using f, and functor provides the ability. Ah, so we were kind of like saying that functor was map on one, apply is like the ability to do two or more. So is that correct? We had it correct in the first instance where, oh, is that why you can't do associativity? Because there's only one for map and this has two. Okay. So can we just make it as simple as apply is map with two or more? Because that would make this like better than this thing, whatever that means. Hmm. Maybe there's something to ask your chat thing. Like, yeah, this is the meat and potatoes which you're not gonna which you got to spend some time on. And I would say the best thing to do is, yeah, like take this concepts and then we have to write the examples because like they have no examples. Like it's pretty stupid. Yeah. Well, the golden sort of result is that you find the example that makes you realize that how it applies to everything, like the universalness of it by coming up with one thing, and because of the way that the language is structured, it should apply theoretically to all things similar to this if you understand the theory. And that's, oh, yeah, I don't mean like, well, I think it's worth creating, and no, no, what I mean is like for all of these things, creating a simple example, like one example, not like the entire prelude, but at least one subset of, yeah, one subset of each thing to then see if it like then informs the next thing. And I think it will. I think the chaining effect would have happened because it's like you can see with apply, it's like you understand functor and then you understand apply. It's like you understand apply and then you understand applicative. It's like, yeah, yeah, yeah. And it's like, and that's what you would expect this book to have. Like, it has these, which this is more the language, and then maybe at this point you start to get to, oh yeah. So it is monadic. There you go. Maybe. It is monadic. Mm. Okay. Maybe we should do this. Canvas graphics. Hello. Hey. Yeah. That'd be pretty cool. All right. Let's leave it there. That was interesting. Mm. Yeah, that's what sort of made me be like, this is kind of worth looking at. Just how much you can get off the ground running by what they supply, but then I think when we enter the documentation for this level stuff, yeah, it's still questionable whether it's easier to just do it in Haskell given their, yeah, and how many people use it and how many like stuff we could just reference versus this thing where we might have to look at the source and some other old repo that might not even compile, and it's like, does this even work anymore? Yeah, and and that's where if we use this stuff and understand it, then it's like, okay, I'm ready to go to Haskell. Yeah, yeah, I saw that they have React bindings and you know other popular like if you could do this in Node, for example, it'd be interesting to do a lot of the asynchronous networking stuff, right? Some of the, especially with the event pattern, like the event pattern's horrific with regards to knowing when things are happening and what to do. It's like maybe if you have something like this, it could make it more sturdy. And yeah, async, like how does async work? Like I'm interested. Yeah. Does Haskell have multi-threading as well? I mean, it is like really low level, so I don't see why not. Cool. Mm. Well, it's sort of made for this language, given how functional you need to be for that sort of problem. So, yeah, and you'd hope this thing as well, you know, has similar features, but if it's bound by JavaScript and has to translate to it, like, can you translate a cancel? Is a question. Yeah. You want to draw a thumbnail for me? Yeah. Let's have a look. If it's not a lambda, I'll be so disappointed. It's not a lambda. Why not? So? But lambda means function. Yeah. I'll also draw one just for fun. I can't even go to this. Okay, it's JS Paint on app. Okay, I did my logo. Oh shit. Oh, you did it? Oh, right. Quickly! 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 Yeah! Have you been playing any games? Oh, yeah. If they update Dota, like, completely, I might, like, try it again. No. Not, like, not different game, but, like a new engine or something. New graphics. Source 4, yeah. Or, like, completely revamp, like, the UI or something, you know, more. Nah. Oh, nice. That's really good. This should be their logo. I would feel like it should be. It's way better. Oh yeah, you did. Nice. You mean the fire? Yeah. Oh yeah, true. You flipped it horizontal. I mean, yeah, along the Y axis. What? Hmm. I actually saw one of these that was like a simpler version of something, and it was of Factorio. It was like a complete like copy. Like it had all the belts and stuff, and it was to do with animals. I think so, yeah. I think it was like one of those Chinese like copy the entire game and just replace everything with dogs or something. Yeah, it looked decent, but it was like it yeah. Like, yeah. Oh yeah. There was like three Factorio clones. Um hmm, what's this? Shapes.io. It's like yeah, that's pretty cool. Sure. It's all open source and JavaScript only. Mm. Yeah, it's not here. I think it was on Steam. Can't remember what it's called. Maybe if you just Google Chinese knockoff Factorio dogs or animals. World's biggest clone factory raises fear in China. Hmm. Nah, animal clones. Alright, GG. See ya.